Welcome to part 3 of my shell scripting tutorial. In this episode I will be discussing conditional logic. First I will be discussing reusable functions. Then I will discuss the logical operators available in the shell for performing a logical AND, logical OR, and negation. Then we will be looking at if-else constructs. And finally I will be discussing the test command to verify properties of numbers, strings, and files, and for comparing numbers and strings. We create a function by entering the name of a function, parentheses to indicate that it's a function, and then curly braces for the contents of a function. We can invoke any function we create in the script simply by entering its name. There is no syntactical difference between invoking a function and invoking a command. Here you can see that I've invoked the yes command. I'm adding an extra function. Now every function has a return code, which I am making explicit here. In the shell, we use 0 to indicate success. A return code of anything other than 0 is considered a failure. After a function or a command is executed, we can access the return code in the variable question mark. If we set the error flag, you will see that the statements after the no function are not executed because an error has occurred, since a non-zero return code indicates an error. Now if these functions don't have any output, then they're actually equal to the built-in commands true and false. So if we execute true, we see a return code of 0, and if we execute false, we see a return code of 1, which indicates an error. Now if I try to echo the return code again, you will see that suddenly we see a success. And the reason for this is because even the echo command has a return code, and echo completes successfully here. So next time we try to print the return code, we get the return code of echo, which is success, 0. Let's make a little bit of a more realistic example. Let's say we invoke the makedir command for the directory bar. And then we print the return code. Here you can see that the makedir bar command was successful. But if we run it again, we get an error because the directory bar already exists. And we get an error code of 1. If the error flag would have been on, we wouldn't have been able to print the return code. So if you want to work with the return codes of commands to make decisions based on what happened, then you'll have to turn off the error code, the error flag, at that point. We can pass arguments to a function the same way we would pass arguments to a command. So in this case, we pass the argument foo to the function die. The parameters of the function are available inside of the function with the same syntax as they would be if they would have been parameters to the script. So here we can see that the parameter foo is passed to the function and then printed. Now the parameters of a function are scoped to the function itself. So when we execute the script, $1 contains the parameter to the script, which is bar, as you can see set here and printed here. Then we call the function with the parameter foo, and inside of the function $1 contains foo, which is being printed here. Then as we exit the function, we return to the original scope where $1 contains the parameter to the script, and bar is printed again. So let's make this function a little bit more useful. The exit function stops execution of the script, no matter where it's called, and it allows us to send a return code for the script. I'm going to change the echo function to print anything that's been passed to the function, and I am going to redirect this to the system error, since when we're calling this function it's normally an error. And as you can see now, after the die foo has been called, we've exited the script, and the return code is 1. Next up are the logical operators. If we have two ampersands, then we're doing a logical AND. With two bars, we're doing a logical OR, and with an exclamation mark, we can do negation. So let's show some examples of that. So here we can see that if the part before the two ampersands is true, then the echo statement will be called. If it is false, then a part after the ampersands will not be called. This can be any command, but there's a built-in command for true and false that return 0 and 1. If instead we do a logical OR, then we see that the second part's only called if the first part returns a non-zero code. So, let's look at an example of a function to test if a parameter is a number or not. Now, the original Bourne shell and the POSIX specification do not have provisions for doing regular expression matching. The Born Again shell does have built-in support for regular expressions. So in order to do a regular expression matching, we're calling the external command expression. It's also possible to use grep. Let me first give you some examples of the expression command. So here I am comparing the value of 1 against the regular expression of any number. As you can see, it completed successfully and it matched 1 character. If instead we match it against A, then we see that it matched 0 characters and it was not a success. Here are some examples of using the expression command to show that it's really printing the number of characters that match. So the dot matches any character, and here you can see that it matches 1, 2, and 3 characters if I have 1, 2, and 3 dots. Anyway, returning to the isNumber function. Here I'm testing the first parameter of the script to see if it is a number. And if it is, I will print that $1 is a number. If it is not, then I will print that it is not a number. We could use this, say, for input validation of our script. If we require the input for our script to be a number, then we could say, is it a number? If not, quit with an error message. We can see that it works, but we're getting the output from the expression command everywhere, which is not what we want. So in our function, we can redirect the output of the expression command to a specifically named file that just deletes any input to it. Let me change this message a little bit. Better. Now we can actually make these two lines a little bit shorter. And now it should still work. What's happening here is if this check is a success, so if this part is true, then the AND will be executed. This part will be true, and this part will not be executed. On the other hand, if this is not a number, then this is not true, which causes the AND to not execute, so this part is not true, and then the OR will be executed. Here's an example of negation at work. As I said, the exclamation mark can be used to reverse the result. Now here you can see that it's a little bit confusing because it thinks that 1 is not a number and A is a number, but that's because we reversed the flag. The test, I mean. This one has been unaffected because we didn't change that line. Now even though we can write the test like this, it's a little bit hard to follow. Normally for these kind of tests we can also use if-else constructs. So in its simplest form we just have an if, a function that's called that has a return value, a then that is executed if the return value is a success, and most of the control flow constructs in the shell reverse the keywords to show that the construct has been closed. So here you can see that the if is only executed if the value is indeed a number. It's possible to add an else clause, which will only be executed if the condition fails. As we will see later, it will only be executed when all of the conditions fail. And now we've got pretty much the same construct as we had before, but it's a little bit more readable. Now the then has to be a separate statement, but we can use the semicolon, statement separator, to put the if and the then on the same line. That makes it a little bit more succinct. Now we can extend the if-else by adding any number of elif clauses, which basically means else if, and check an additional condition. The last else will only be executed if all of the ifs if the if and all of the elifs fail. So in this case, I am going to check the input against a different regular expression. And else if also needs the then. And this regular expression skips any number of characters and then sees if there's any number of digits in it. So, to give some examples, A is not a number, 1 is a number, and A1A contains a number. So you can see that the expression works. Oh, one last thing I want to mention. I mentioned earlier that you can comment out lines with a hash, but it's not possible in shell scripting to do a block comment. So for instance, Java and several other languages could use this construct to comment out a block of code. But the shell has no such construct. But what we've learned right now, there is a sort of similar thing we can do. Now the end part, and we're making a block of code by using these parentheses here. The end part is only executed if the first part is true, which is never going to be true because this function always returns false. So after this modification, the whole block of code is never executed. Now there is one limitation with this. It's not really a comment, so the code has to be syntactically correct. If we were to comment out every single line, then syntax errors would not matter. There is one last thing which I should mention regarding if-else constructs in shell scripting. In shell scripting, we use the return value of a command both for verifying that an error has occurred as for a Boolean value in if-else statements or any conditional logic. This has a problem. It means that we cannot differentiate between a Boolean value of false and an error occurring. Let me show you this with an example. So I'm setting the error flag. I am comparing the first value that's passed to the script against the regular expression contained in the second parameter. And here I am comparing the digit 1 against the regular expression for a digit. As you can see, the regex matches. And execution continues normally after the if. Now if we were to compare the value of a against the regular expression for a digit, then there is no match and execution continues normally. But let's say I take the first example and there's a problem with the regular expression. What happens now is there's an error that occurs because the regular expression is not valid. So we go into the else of the if, and then we complete execution normally. But since it's an error, you should have actually stopped execution. But there's no way to do this. So at this point, we have discussed in some detail if-else constructs and conditionally executing individual lines of code. But we haven't really discussed how to compare different values or to test certain properties of vowels or numbers and that sort of stuff. For that, we normally use the test command. I'm giving you an example here. So this script compares two values, and if the first value is greater than the second value, then we get into the if, and in all other circumstances we go into the else. So here we can see that 1 is not larger than 2, 2 is larger than 1, and 2 is not larger than 2. Now if you're used to programming in different programming languages, and you look at this construct, then this looks like a syntactical construct based in the language itself. That's not what's going on here. The square brace open is actually a command. It's the test command. So if I type it like this, then you will see that the shell is trying to find, or I should use actually the Bourne shell. dash, I mean. But if I type it like this, then this command is not found. If I type it like this, then the command is found. It has taken the argument of the square brace close. And the return code was false because this is not a valid test. Next example. Here I'm writing a test to see if the value of A is equal to the value of A, which is a success. They are equal. Now I'm comparing A to B, and those are not equal. Once again, to show you that it's actually the square brace command that's being executed, if we forget the space after the first square brace, then suddenly it's trying to execute the command square brace A, which does not exist. Alternatively, this also doesn't work. It's complaining that there's a missing square closing brace. And the reason for that is that right now it's comparing the value of A to the value of A square brace, and it is expecting a standalone brace at the end. So for instance, we could write a test and this would succeed because A square brace is equal to A square brace. The square brace command, or the test command, actually has its own manual page. So here you can see some of the flags you can use. There's some flags for string comparison, for comparing integers, and there's a lot of file tests available. As we saw in the manual page, it's actually called the test command, and there's another way you can run it as well. Oops. As you can see, this works. You don't need the square closing brace like this. The command's smart enough to detect that. So here's a non-conclusive list of some of the tests which we regularly use. For numbers, you can check to see if the first value is greater than or equal to the second, greater than the second, less than the second, less than or equal, equal to the second, or not equal to the second. All of these tests take 2 parameters. For strings, only the first 2 take 2 parameters. You can test to see if the values in 2 strings are equal, not equal. These one take a single string, and the first one, I believe, checks to see if the variable is actually set, and the second one checks to see if the variable or if the string is empty. You can use conjunctions and or conjunctions to combine multiple tests in one line. And for files, the most common ones are to check if a file path exists, if it's a directory, if it's a file, and we can also check if something is a soft link. So let's start with some of the examples for numbers. They're quite easy to remember, but they're a little cryptic. So let me give you some example usages of the test command, starting with numbers. As you might remember from earlier episodes, we can test the amount of parameters. We can get the amount of parameters with the hash variable. Here I'm saying that if the amount of parameters to this script is not 2, then print an error message. So showing that in use. And there we have it. So usually when we write scripts, there's a certain contract that we expect from people using the script. Usually scripts have a certain amount of parameters which they require, and this is an easy way to verify that the script has been invoked properly. Alternatively, we can do the exact same test. So now we're testing, the test checks the amount of parameters and compares it to 2. And if it's 2, then the OR is not executed. And if it's not 2, then we get the error message again. All right, that's working. And there we have it. Now, alternatively, we might have a script that takes at least 2 parameters. We'll have to go a little bit further. Well, we actually could create a script right now that takes 2 and an optional third parameters, but it makes more sense when we have loops. So what we're doing now is we're verifying that the amount of parameters is greater than or equal to 1, or we show an error message. As you can see, it's working. Alternatively, this would be useful for instance, an installation script or something. We often want to test that the person that's executing the script actually has privileges to do so. One way to do this is we can get the ID of the current user, and if that's 0, then we are root. So here you can see under my normal user, the ID is 1001, and if I'm root, then the ID is 0. So in our script, we could do let's use an if-else just to show that that's also possible. So let's test it. So here you can see that if we're running the script as a normal user, then we get an error message. However, if we're running it with the privileges we need, then it works. We're not actually root, we just have privileges for root. There's an alternative trick which you could use at the beginning of a script. So using this little trick, what happens here is once again we're testing for root access, and if we don't have root access, we run the exec command, which replaces the current process. So the script so we currently have a script running. That script is aborted and it's replaced with the command that follows this, which is sudo the current script and all the parameters to the current script. So basically what this does, this replaces the currently running script, if you're not root, with the same script but with root privileges. And then the next run of the script comes up until this point and the task passes, so it just continues normally. It's a little trick to put at the beginning of a script if you always want the script to be run as root. That simplifies, then you don't give a warning to the user, but it just fixes the problem for him. So let's look at conjunctions for a little bit. If we have multiple tests we want to do, we can use the -a for an AND or the -o for an OR. I'll just give an example of an AND here. So in this test, I am comparing the first parameter to the script and checking that it is greater than 3. And I am also checking that the first parameter of the script is less than 8. So basically I'm defining a range from 4 to 7 in which the input, the parameter must be. And as you can see, it's working. Now, I just showed you a test for determining if you have root access by using the ID of the user. But I'm still going to show you that there's another distinction we can make, and that's whether we are root or not. And I'm going to use a string check for that. In order to make that possible, I'm going to look at the home dir of the current user. So as you can see, if I run the script normally, then I don't have root privileges and I'm not the root user. If I run the script with sudo, then I do have root privileges, but I'm not the root user. So if I become root, now you can see, let's run it the same way. Now you can see that I have root privileges and I am the root user. This distinction can be important in scripts because in some cases you want to be able to run the script as a root with root privileges. For instance, you need to install packages. You're required to do anything on the operating system which requires administrator rights, but you don't want the person to be root. Because if you're root when you run the script, then all of the files that will be created will belong to root. And this is a simple, so with these two tests you can distinguish between the different situations. Let's go to some file tests. As a first test, I'm going to verify that the file that we're passing as a parameter actually exists. And as the second test, I am going to see whether it's a file or not. And let's check whether it's a directory or not. So the flags chosen here are pretty easy to remember. Exists file, directory, EFD. let's run some tests. So demo, the name of the script itself, exist is a file and is not a directory. Dot refers to the current directory. It exists, it's not a file, it's a directory. Let's create a soft link. The link exists, it's a file, it's not a directory. So this is a little bit tricky. It says it's a file because it refers to a file, but it's not actually a file, it's a link. So one of the ways around that is you could, for instance, add an additional check. The capital letter L, and I believe the other one is H, but I'm not sure, will verify that it's a soft link. And I'm negating it because I don't want it to be a soft link. So now you can see that link exists, it's not a file, it's not a directory. And demo still works, it exists, it's a file, it's not a directory. So one very simple usage which is common with these kind of tests is when you're creating a directory, this command normally only works without any error messages or failures if the directory doesn't exist. So if I call demo, it runs without any error messages. If I call it again, then we get an error message because the directory already exists. So we're going to do a test first to check that the directory doesn't exist, that the location doesn't exist, because there could be a file with the same name. Now we don't get an error message, but it's also not very clear what's going on. So we're creating the directory now, and now we get the message that it already exists, but the script continues normally. So let's look at some examples that make use of what we've learned so far. Let's create a new file named goo and give it execution rights. And we're going to use the script goo to enter a search term in Google. So in its simplest form, we simply open the Google website. Now when we're on the Google page and we enter a search term, you can see that Google redirects us to /search, where it enters the Q parameter with the term we just entered. Any spaces between words will be replaced by pluses because spaces aren't valid in HTTP. So let's modify the script to check the amount of parameters. And if there aren't any parameters, then we'll just open the Google page. But if we did enter a search term, then we fill the query parameter. And the parameters that will be entered are all of the parameters passed to the script, where we've replaced the spaces by plus signs. So let's test it. Almost. need to go to search. There we go. Now we can directly search Google from the command line. And if we don't enter any parameters, then we just go straight to Google. Now for the second example, I will create a simple script that will unpack different kind of archive files. So let's create a simple file. And now we're going to create both a zip archive and a tar archive for this file. Wait, something went wrong there. Ah, got it. Should be space. So we have a tar file now and a zip file. Now if you'd want to unzip the zip file, then you'd simply say unzip z.zip. And you can see that we have the file again. But for the tar file, you would have to use the tar command with the xf flags. And you can see that the file exists again. Now there are actually many kind of archive files, and for every kind of archive file you have a separate command that you need to use, or a command that you reuse, but you need to change the flags depending on the type of archive, which can be a little bit of a pain to remember. So when I just started working with Linux, Paul, a friend of mine, he gave me a simple script that figures out what kind of archive it's dealing with and just use the appropriate command and the appropriate flags to unpack the file. So we will be creating that. A simplified version of that script. So first off, let's do some input validation. Let's say this script accepts exactly one parameter. And in case it doesn't, it throws an error. Now the first thing we need to know is the file extension. The file we are going to unpack sits in variable number 1, in parameter number 1. And I'm going to remove everything before the dot. So that should give me the file extension. So let's test what we have so far. Okay, so it's able to determine the file extension. Now based on the file extension, I'm putting quotes around it in case nothing is left. If it's a zip file, then we use the unzip command. With the full file name. However, if it's a tar file, then we use the tar command. with the appropriate flags. Let's print an additional message. And want to indicate that it's a tar if it's a tar. Okay, so now we have a simple script file that can switch between the archive files. And as you can see, we can now unpack the file regardless of which extension it has. Now this is the actual script file that my friend gave to me. And as you can see, it only verifies that the first parameter has a value. So if you'd give this script 2 parameters, then the second file would simply be ignored. Also, it doesn't store the intermediate result of the file extension, but it just repeats it with a different if every time, which is less efficient, but you're probably not going to notice the performance difference unless your computer is really, really slow. Also, there's a lot more file extensions supported in the original file, which is ace, rar, zip, tar. I don't even know how to call these two. gzip, bzip. And it uses a full if for every case, which isn't really a problem because there aren't any duplicates. So even if it runs a check for every if separately, it doesn't really matter that much. But I guess the elif is a little bit of a cleaner solution. You could actually use a case statement here as well, but I haven't discussed that yet. So that completes the examples for lesson 3. I hope this was useful, and I hope to see you in the next episode.